A warm welcome to you all. We are going to discuss about the topic Direct Memory Access DMA. So it is present in Madras University syllabus for the UG Computer Science students. The course name is Computer Organization. Belongs to 5th unit DMA, Direct Memory Access. Here we are going to discuss about introduction. What is DMA? What are all the pins available in 8085? We will see the diagram first. Microprocessor will always helps for data transfer between memory and input-output devices. So the microprocessor, with the help of microprocessor only, the memory and input-output devices can transfer the data. When the amount of data is large, then the microprocessor could not hold all the data until it is transferring. So we will have a concept called direct memory access. So the DMA controller will present in between the memory and input output devices. So it will control the memory and input output devices. So that topic is called as a direct memory access. First we will see what is direct memory access. You can get the meaning direct. Direct means we are going to access the memory directly without the use of microprocessor. That is called as direct memory access. So this technique is used when there is a huge amount of data has to be transferred between memory and input-output devices. So the DMA controller will reduce the operations of a microprocessor. So the microprocessor can give the control to the DMA and then you can do some other work. So for this we are going to use the DMA. So the DMA concept will used when we have to transfer large amount of data between memory and input output devices. So it's a technique which is used for high data transfer also. So the speed will be very high when it is transferred with the help of the DMA. When data is transferred with the help of DMA. So the DMA will present between the memory and peripherals. Peripheral is nothing but an input-output devices. The microprocessor will give all the controls to the DMA. Control means control of address bus, data bus. It will give all the controls to the DMA. Then DMA will take the charge and then it will start transfer the data. So the DMA controller will manages the data transfer between the memory and input-output devices without the help of microprocessor. So it is going to act as a microprocessor during the large amount of data transfer. This concept is used in order to reduce the microprocessor's functions. So for that purpose only it is using it. We are going to see the basic definition. Direct memory access, it normally occurs between input-output devices and the memory. We are not going to use the microprocessor. So without the use of microprocessor, we are going to transfer the data between memory and input-output devices is called DMA. That is direct memory access without the use of microprocessor. This is the definition. DMA read, it means we are going to transfer the data, that is we are going to read the data from the memory to input output devices. So that is called DMA read. So it will transfer the data from the memory to the input output devices. DMA write. DMA write means we are going to transfer the data from an input output devices to the memory. So read means from memory to input output devices. That is, we are going to read the data from the memory. Write means we are going to write the data from input output devices to the memory. So we are going to write the data to the memory. So we will have a separate memory and input-output control signals will be present. In DMA concept, the memory and input-output are controlled simultaneously by the DMA controller but not by the microprocessor. So the microprocessor burden will be reduced by the DMA in case of large amount of data transfer. So this concept is used when we are going to transfer large amount of data between the memory and input-output devices. So in this concept, we are going to reduce the burden of the microprocessor with the help of DMA. So in 8085, we have 40 pins. 40 pins is present in an 8085 microprocessor chip. In this, 2 pins will be used for direct memory access. Pin number 39. It is used for hold signal. It acts as an input. Pin number 38. It's called as an HLDA signal. It acts as an output. You can see in the pin diagram, hold, HOLD, hold signal, it is going inwards to the chip. So it's called as an input. Pin number 38, HLDA is going outward. So it's called as an output. The signal will comes out of the microprocessor. Now we are going to see what are the 2 pins will represent. Hold, pin number 39, it acts as an input. Hold pin will use to request the microprocessor for DMA transfer. Suppose if large amount of data has to be transferred from memory and input-output devices, then pin number 39 will give a request to the microprocessor for its control for the DMA transfer. So at pin number 39, when the signal is high, so it's called as request to the microprocessor. So on receiving this signal, the microprocessor will relinquish the holds on all the buses. It will release the control of the address bus and data bus and gives the control to the DMA. So the DMA can take charge and then it can start transfer the data between memory and input-output devices. This request is sent by the DMA controller when we have to transfer a huge amount of data. This request is given to the microprocessor through pin number 39. So once the pin number 39 input goes high, the microprocessor understands that DMA is going to transfer huge amount of data between the memory and input-output devices. Next is pin number 38. It's called HLDA, that is hold acknowledge. Once the microprocessor receives the pin number 39, that is hold signal, it has to respond to the DMA. That signal is called as an hold acknowledge. So the microprocessor uses this pin to acknowledge. Acknowledgement, it's answering to the request. It is responding to the request given by the hold signal. So the DMA is getting permission from the microprocessor. So it is giving a request to the microprocessor. So the microprocessor gives permission to the DMA by giving an acknowledge signal. So the microprocessor uses this pin to acknowledge. This pin means pin number 38 to acknowledge the receipt of hold signal. So it's getting the request. So it is responding to DMA. So once the HLDA signal goes high, then the address bus, data bus, read, write, input, output, memory pins, everything will get the control by the DMA. The microprocessor will give the control of these pins to the DMA. So then DMA can start transfer the data between the memory and microprocessor. Tri-state means we are going to share the address bus and data bus control bus between the memory input output devices with the microprocessor it will have. So memory input output devices will have all these buses connected with the microprocessor. Now we are going to insert a DMA controller in between these two, and then we are going to use these buses for the data transfer. So it's called as a tri-state. That is, these address bus has been shared by microprocessor as well as by the DMA controller. It's called as a tri-state. Then the microprocessor will be gets disconnect from the external environment. So now the DMA will take charge for data transferring between the microprocessor and input output devices. The control of these buses will goes to the DMA controller. Now DMA controller take charge, and then it will start transfer the data between the memory and the input output devices. The control remains at the DMA controller until the hold signal is high. Once the data transfer has been completed, then the hold signal will goes low. When the hold signal goes low, then the response HLDA will also goes low, and the microprocessor will takes the control of the buses, and then it will start have a connection between the memory and input output devices. Now the DMA will depart from the data transfer. Once it has been completed, it will get depart from the input output devices and the memory. So that it goes when HLDA goes low, this concept will work. So once the data transfer completes, hold will goes low. Once the hold goes low, HLDA will, that is the response will become also low. Once it gets low, microprocessor will take charge. So this is the concept used in DMA. The DMA controller will have the data bus, address bus, read and write control signals and control signals. All these will be controlled by the DMA controller. So I am going to conclude here. DMA controller will present in between the memory and input output devices. So we are going to directly access the memory without the use of microprocessor is called direct memory access. The direct memory access controller has been programmed in a chip. Example, we will have Intel 8257. This chip acts as a DMA controller. It is a programmable DMA controller chip which is present in between the memory and input output devices. The next video we will see in detail about Intel 8257, how it works and all. Thank you.